Welcome everyone to today's webinar, Industry Roundtable, How to Foster Resilience in Times of Crisis, sponsored by Enchanted Rock. I am Brian Zimmerman from Becker's Hospital Review. We'll begin today's webinar with a panel discussion, and we'll have time at the end of the hour for an audience question and answer session. You can submit any questions you have throughout the webinar by typing them into the Q&A box you see on your screen. We look forward to hearing your questions. Today's session is being recorded and will be available after the event. You can use the same link you used to log into today's webinar to access the recording. And it's now my pleasure to introduce today's panelists. So we have Mike Olson, who has been CEO of Citizens Medical Center since November 2015. He has more than 2 decades of healthcare leadership experience. At Citizens, Olson oversees all functions of the hospital with nearly 1,000 employees and over 250 physicians providing exceptional patient care to those in the regional area, utilizing the latest in medical technology to deliver care in a personal way. Abigail Lipperman is a licensed professional electrical engineer and senior infrastructure project manager for Children's Health, a leading pediatric healthcare system in North Texas and one of the largest pediatric healthcare providers in the nation. Abby has spent more than 12 years as a consultant specializing in the design of complex hospital electrical distribution systems. In 2009, Abby was selected as one of the Consulting Specifying Engineer magazine's top 40 under 40 and was recently recognized as a certified healthcare emergency power professional by Motor and Generator Institute. Jason Shore is currently the practice executive for the HKS Health practice and stewards the firm's aspirations for outcome-driven design. He's an architect with over 21 years of experience, focusing his entire career on spaces and places that support healthcare. He leads, serves, and connects the global HKS practice across 21 different offices. Alan Scher is the Chief Commercial Officer at Enchanted Rock. Alan joined the Enchanted Rock team in 2018 and brings go-to-market expertise from over 30 years of experience in commercial and industrial energy services and innovative utility solutions. Scher is responsible for corporate and product marketing, direct sales, and channel sales functions. He is also a registered professional engineer in the state of California, and he is a co-inventor on 7 patents related to distributed energy. Thank you all so much for being here. We're going to have a great discussion with this really wonderful group. But to kick things off, we'd like to start with a poll question. So take about 20 seconds to answer the question. So the question is, of course, have you considered full facility backup power for your existing and or upcoming new build facility? And you see those answers there. We'll give you about 20 seconds to select it, and then we'll see what we get. All right, I think we can go ahead and go on the results. Here we go. There you are. So panelists, I want to give Alan or anybody else the opportunity to comment here on these poll results before we dive into our discussion.
Yeah, this is Alan. I was hoping we would see results such as this because of this topic being of such interest. We have over 500 registrants for this particular webinar. You'll hear a lot more about actual practitioners related to the value of having full facility backup, but I'm glad to see that over a quarter of the attendees are actively looking into it.
Certainly, good to know before we jump into this discussion. So I think we can go ahead and get started then. And Mike, I'd like to begin with you. So the first question that I have is, what happens if a hospital is not resilient?
Thank you, and good morning, everybody. Thank you for joining us. Well, what happens if a hospital is not resilient is it's not good. That's the short answer. There's a lot of challenging situations that can occur if a hospital is not able to be available to the patients and the communities that they're there to serve. This is especially true during natural disasters or a pandemic, where people are relying on us for emergencies and critical care and all those sorts of things. And most hospitals have backup systems in place in the event of a power outage. but most of them just have diesel generators that kick on with the loss of power, and they can't provide power to everything in the hospital, only to critical or life safety areas like red plugs and things of that nature. And the problem with that is, it doesn't support things like air conditioning, where you can keep the facility cool and dehumidify the air, that sort of thing. And those kinds of challenges can be very problematic if this happens over a long period of time. And our hospital experienced that back in 2017 with Hurricane Harvey. We're about 50 miles off the Gulf Coast in Texas, and when Hurricane Harvey came in, we sustained very high winds and catastrophic losses in our power throughout the whole area. We were out of routine power for probably 2, maybe 3 days, so operating on backup generator power. And the problem with that, like I said, is the buildings began to sweat. Humidity collects and starts dripping from the ceilings in the OR, off of equipment, walls, etc. You cannot perform surgery safely in that environment. We also happen to lose water from the city water supply. So for that reason and others, we ended up having to evacuate hundreds of patients from our area and from our hospital to places like San Antonio. So the impact was significant on our patients and our community, who really rely on us to be able to take care of them in the time of an emergency. We service over 250,000, 300,000 people in our area, and being resilient is essential for us to be able to maintain operations and keep things going and be available to take care of people with those emergency and critical needs that might come up, especially during a natural disaster. So that led us as an executive team to really think about what can we do to make sure that we're better prepared for that in the future. And that led to our relationship with Enchanted Rock, where we now have 7 natural gas generators on site that can provide power to our entire hospital, including our HVAC, our air conditioning, and everything else. So not just our critical care areas or life safety, but our entire hospital. And that is a huge deal. Most hospitals do not have that capability. So that makes it possible for us to just continue to operate pretty much routinely, as long as we don't have significant physical damage to the facility. So we are really, really excited. As we've gone through this last hurricane season, it's been really comforting to know that we have those systems that fire on almost instantaneously if we lose power, and they can run forever if necessary, and provide support to our entire hospital.
Mike, that definitely sounds like an exciting capability there. Abby, I'll let you go ahead and jump in. Apologies there.
Yeah, definitely. Thanks. I was just going to say, we haven't been affected by a hurricane in quite the same way, but we have had a few normal power outages just from different events. One of our facilities lost power for a few hours due to a car crashing into a power pole, and another building lost service due to a fault at the utility company vault. And so, there was this great big fireball that blew out the doors to the substation. Animals can get into switchgear or transformers and cause faults. And so there's a lot of reasons that normal power outage may occur. Even if you're not in an area that is prone to natural disasters, you may still be at risk. And so when that happens, the doctors at our hospital tell us the seconds feel like minutes and minutes feel like hours. Everything just slows down, and surgeries and other critical operations are halted, and the hospital really goes into survival mode to keep patients safe and conserve resources. And, like Mike said, supporting services may be interrupted. Kitchen and dining services, administrative functions, other non-critical areas will be impacted, and so users will start to use what they have. They'll start moving things maybe from normal power to emergency power to the red plugs that are there. And so, like Mike said, most hospitals are designed to carry loads only required by code, unless the owner requests optional loads like chillers and air handlers that serve other spaces to be supported. So resiliency is a huge concern for healthcare.
No, most definitely. I think it being 2020, everybody understands, whether they're in an area where a hurricane can come or not. I think everybody understands that things can go wrong, and it can be a big challenge. So having a resilient facility, a resilient hospital, is so important. And with that in mind, thinking about, how much it matters how much the community relies on these places for care to make sure they're up and running during challenging times for the community. I'm wondering, Jason, if you can talk about, how that influences the priorities when designing a new hospital. What are the priorities when you begin designing a new facility like that?
Yeah, well, obviously they're going to, be weighed based on location and context of where the facilities are located. I think the key is, as architects, it is our obligation to be sure that these conversations are had as part of the design of any new hospital, or even when you're looking at master plans or facility assessments, is to do some risk assessments. And, obviously the resiliency comes in a lot of different forms, whether you're looking at storms, sea rise, seismic threats, fires, heat, your IT network, war, terrorism. There are a lot of different, aspects. And of course, what just kind of hit us hard recently, and we're still in, is pandemics. And so it's really just important for those conversations to be had with facilities and clients to go through those risk assessments and determine, what are actually really threats, and then where do you really need to plan. And it's just kind of part of our due diligence that we have to have up front with clients. And then you begin to prioritize amongst those threats on which ones you really think you need to maybe spend a little bit more money on, or look at some innovative solutions on how to handle that. When it comes to power, obviously, we think of power a lot of times as the blood that runs the facility. Without that, a lot of other things don't run. And so that's always going to be an area in which we want to focus some attention on when we talk about resilience, regardless of location or threat type.
Thank you so much for weighing in there, Jason. Appreciate it. And so we talked a bit about like what can go wrong already, and I want to circle back to sort of Mike, Abby. I think you've sort of touched on my next question already in your previous answers a little bit, but what does a resilient hospital look like? What does it actually look like? Either of you want to weigh in there?
Sure, this is Mike. I'll take a start at it. So I think being a resilient hospital is a hospital that is almost self-reliant, that you have anticipated what could happen in the future, and you've tried to put in systems and processes to make sure that you can maintain operations during whatever circumstances may come at you. And I think that being able to fully function with power is vital and essential. So you need to have a system and a process. And it would be prohibitive for us to put in enough diesel generators to be able to cover our entire hospital. It'd be very cost prohibitive, and it would also be very difficult from a space and logistics standpoint as well. So the solution we came up with the natural gas generators, they're efficient, they're quiet, they are very powerful, they don't take up near as much space, they're very economical in that respect as well. So for us, it's really, really neat to have that capability. And we have to look at everything. So for water, for example, we ended up having to drill a well, get permission from the city to drill a well to get a water source for putting into our cooling towers so that we can continue to maintain a water source now that we have power. So we had to look at all those different aspects and figure out how we can make sure that we are going to be here for our patients, because they're depending on us. They're expecting us to be here and be able to support their needs. So I think that's what being a resilient hospital is all about.
Yeah, I agree with Mike completely. I like the Department of Energy's definition for resilience is the ability to adapt to changing conditions and withstand or recover from disruptions. And so in a hospital, disruptions, especially to power, can be devastating without proper planning. I think that's definitely a key component, like Mike talked about, was just having a plan in place of what happens if. Patient safety is our number one priority, and oftentimes power is essential to ensuring that the critical equipment and operations stay online. One way that we've been evaluating resiliency at one of our facilities is to look at full building backup. And so we have a site, our existing generators are aging, they're having some problems. we began to lose confidence in their ability to pick up the load. So we brought in a rental unit and we performed a full emergency system study to determine how to proceed next. And so our key expectations were to, number one, pick up code required loads. Number two, pick up the chilled water system and equipment so we could have cooling, especially here in Texas. And number three, evaluate full facility backup. So normal and emergency power picked up while taking into account future expansions. And so we wanted a system that can give us reliability and redundancy options to ensure that we have power available at all times. We also wanted to be demand response ready and participate in utility incentive programs. And then we also wanted a true central plant. We wanted to be able to support multiple buildings on our campus instead of having multiple generators at each space. So after performing that evaluation, we actually found that full facility backup was going to be more cost effective and a better overall solution for what we were trying to accomplish than separating out some of the optional loads, especially in an existing facility. Restructuring some of the infrastructure to pick up our chillers and pumps and associated HVAC systems. And it was going to be a lot more cost effective to do that than providing traditional diesel engine generators.
Thank you, Abby. And I really, really appreciated the definition you shared there, right? Like resilience as this ability to adapt and sort of recover as well. And so how do we achieve that? How do we achieve a resilient hospital? Alan, would you be able to start us off on this question? How do we achieve a resilient hospital?
Well, yeah, thanks. I think Abby mentioned this, but power is foundational to a resilient hospital because systems depend on having electricity to function. And so the beginnings of a resilient hospital have to do with assessing the needs for what it would take to do full facility backup. There have been some concerns in the poll raised around, is this even cost effective? I'll get to that in a second, but the ideal solution does provide every aspect of the hospital complex with power on a continuous basis without some of the disruptions that even backup generation can experience over time. As an example, the gas-based microgrids that we're talking about here have an indefinite fuel supply, and so they can run for days and days without having to worry about refueling tanks and fuel availability, which in certain emergencies can be a challenge. The emissions levels are ultra clean, and so the air permits don't limit the ability to operate in emergencies and in non-emergency mode. And so that enabling technology of a microgrid as a replacement or a complement to the life safety loads that the diesel, typical diesel generators can provide, give an opportunity to really just have normal operations. Even in the middle of an emergency, every system is running. There's adequate capacity for all aspects of the hospital to operate. And in a COVID world, what is critical is really changing. And so those choices, those trade-offs don't have to be made when you can count on utility grade power as if there was no disruption at all. The magic of these microgrids to make them work economically, because I don't think any hospital operator would disagree that they would love to have full facility backup. To get it cost effective, that microgrid can be very affordable, can be even the same price as the diesel plant for a portion of the hospital if it is operated in conjunction with the grid. And for those of you in the healthcare field that might not be familiar with how the electric grid operates, every second, every subsecond, it has to balance supply and demand. That real-time balancing sometimes creates conditions where there could be shortages of supply on very hot days, or when part of the grid or power supply has problems and is no longer available. Having the ability to provide dispatchable capacity into the grid at a very short notice, seconds really, creates a revenue stream. That revenue stream is substantial. It's a substantial revenue stream in Texas, where we've looked at these examples. It's substantial in the Northeast, on the West Coast in California. The ability to create that grid support service from the same asset that would be available when there's an electrical emergency from a grid outage is what makes these very affordable, makes the vision of full facility backup a reality, because the economics are very comparable to having just diesel for a portion of the backup.
Thank you, Alan.
Abby.
Go ahead, Abby.
Oh, I was just going to kind of reiterate what Alan had said. As we started to look at options for full facility backup, we went through the traditional emergency system design with paralleled generators, diesel engine generators, and we were actually approached by our local utility company to look at a microgrid. And so, once we looked at it, we found this was a really great opportunity. We'd get the benefit of full facility backup, have that resiliency built in, support multiple buildings, cleaner energy source, all for much less cost than the traditional parallel diesel engine units that we were considering. And so by evaluating this option, there were multiple benefits. The microgrid could wrap around our existing emergency diesel units to provide full coverage. We will still maintain our code-required generators for life safety critical equipment loads, but the microgrid would be able to be connected to pick up everything else, just as a local utility generation source. We could support the entire campus, so chillers, HVAC, humidifiers, full kitchen and dining, all support spaces across multiple buildings. We'd have that reliability during critical events, whether it's natural disasters, weather, or just if we feel that normal power is unreliable, we can just make a phone call and island ourselves from the public utility. We liked it also because it's scalable for future growth. We have upcoming expansions on campus, and so we can scale it as the site grows. Like Alan said, it's clean and quiet. It would be much cleaner and quieter than our Tier 2 diesel units. And the unlimited fuel supply is definitely a huge benefit. So we can run a separate natural gas service straight to the microgrid, and we wouldn't have to worry about storing fuel oil or bringing in trucks during a disaster. And then finally, one other benefit with our engineering department is that under a master service agreement, there's no maintenance. We would not have any operation or maintenance responsibilities for the system. So that was a huge part of our evaluation as we look at providing resiliency to our hospital.
This is Mike. I was going to comment on that same exact point. It's really neat that these 7 natural gas generators that we have are maintained and operated by Enchanted Rock, and they do all of the service maintenance, all the things that need to happen. So we basically have a long-term land lease in place for these generators on our property, and there's no exchange of money for that lease. It's just that they will continue to provide that services that they agreed to in their master services agreement, and to provide that support to us as needed. So it really becomes very, very affordable, for us to be able to have that capacity to power our entire hospital. We could never do this independently of this arrangement.
Thank you, Mike. And it sounds like, a resilient hospital can be defined as sort of one that is equipped for full facility long-term backup that can support really normal operations. You don't have to make any trade-offs. And then we've touched on certainly the economics of this, but I'm wondering if we can dig a little bit deeper. So can resilience in the hospital space be affordable?
This is Abby again. And this is really one of the main reasons that we are currently evaluating a microgrid solution. Many of the new technologies for microgrids offer a master service agreement or a power purchase agreement of some sort, and it provides a pretty substantial initial capital expenditure funding in exchange for the incentives or revenue streams that are associated with the energy utility. So for a buy-in of a percentage of the overall microgrid cost, it's still a huge savings over traditional diesel, but we still gain all the benefits of full facility backup. So in the model that we're currently evaluating, we'll also we're looking at transitioning from a secondary service to a primary utility service so that we can connect the microgrid upstream of our campus. And just by this transition alone, there's an expected savings on our monthly utility bills for that term. Again, the operation and maintenance piece, just the cost of operation and maintenance from our engineering team will be provided by the vendor, and so there's a savings there. And so when you think about the total cost, you know, our contribution to provide backup power to the entire campus could potentially be less than the cost of some medical equipment. And the savings that we will see from avoiding lost revenue in the event of an extended outage may more than cover the cost of the initial contribution. So I think it's definitely an affordable option.
And this is Mike. I want to...
Oh, go ahead, Mike.
Let me just comment real briefly on this as well. So during the Hurricane Harvey, we had business interruption that probably was in the multiple, you know, it was multiple millions of dollars for us in operational losses that we incurred. That had we been able to be operational, we wouldn't have had to incur some of those losses that we did. So that's one issue. But also on the affordability side, yeah, exactly what Abby was saying. We looked at this, and we would have had to purchase probably 2, maybe 3 additional diesel generators and parallel them together to be able to provide the redundancy that we would need and the capacity for our entire plant. And the cost would have been in the multiple millions of dollars to facilitate that. We were able to partner and work with Enchanted Rock under this arrangement and do it for a fraction of that cost, you know, hundreds of thousands instead of multiples of millions, and to have that backup power and that capability for our entire campus. So I definitely feel like it is affordable and reasonable. It may be something that particularly if you're in an area where you're vulnerable or at risk of major outages of power, this is something you definitely need to consider and look at and for the long term.
Maybe this is Alan. Let me add just a couple of details about how these economics pencil out in different markets. I mentioned earlier that the wholesale electric market is constantly seeking to balance the supply and demand equation in real time. On a per kW or per megawatt per year basis, if you looked at the on-site generating plant, a megawatt of backup can earn in different markets somewhere between $50,000 and $200,000 a year in grid revenues if you're managing it optimally. And sometimes that management means there's a price signal that is received, and within a minute or two you have to respond to that price signal and parallel the gen plant to be able to take advantage of that signal. In other cases, there might be a hot day where you can anticipate achieving a certain peak that will ratchet up on your bill over time. The aggregate of all these different localized programs, sometimes utility to utility, is that $50,000 to $200,000 per megawatt year. And in Enchanted Rock's case, our business model is that we offer this resiliency service where we take all of that market risk from the grid services revenues, and our investors ask for a competitive return, but whatever is still required to make them whole is what we charge our customers for that resiliency. So in the case of Citizens or Children's, the market revenues were significant when we look out over 10, 15, 20 years sometimes. And so it can be extremely cost effective for hospitals that have very high load factors for electricity, that they can benefit from exercising these generators. Might only be 100 or 200 hours a year, which happens to be an excellent loaded test, by the way, but exercising these generators very opportunistically and generating a significant amount of revenue from that generator plant then just reduces the cost of resiliency. Almost too good to be true, but in fact, the merging these two markets together makes this possible.
Thank you, Alan and Mike and Abby for weighing in on that one. Before we move on, Jason, I want to give you the chance to sort of talk a bit around this as well.
Yeah, thanks. I was just going to chime in quickly and kind of play Captain Obvious here, but you know, it's our obligation as design professionals to have these conversations and also help our clients make these smart decisions along the way. And it's all about, you know, weighing that upfront capital cost of these systems versus their long-term return. And oftentimes mistakes are made when you don't really factor in something that Mike mentioned earlier, which was, you know, what are the losses that could be had if we do have systems go down, and you know what cost comes with that. And as you begin to evaluate these based on a 3-year return, a 5-year return, a 7-year return, a 10-year return, or whatever that formula looks like, it's important for us to provide that information to clients for them to make the good decisions on prioritization of where they will perhaps spend those additional dollars to get those long-term savings.
Yeah, no, definitely. I mean, I think asking the question, you know, what are the losses we could have if our systems go down, sort of answering that question then makes the case for why you really need a resilient hospital. For this next question, we're gonna take one more question, and then we're gonna move on to our audience questions. But I just have one more question for the group. So when it comes to designing a hospital, what other considerations come to mind? Jason, would you like to kick us off with this one?
Sure, I'll chime in real quick. What's come up a few times is code, and obviously, you know, code is relatively stringent when we're talking about hospital design. But what we have to remember is that that's just the minimum. That's the design minimum. And so when we engage in conversations about design of systems and the architecture around them, it's important for us to have the conversations also around best practice. And that's typically different than minimum. And then you begin to balance, you know, those costs between what might be minimum and what might be best practice. Other considerations are general ideas around sustainability, and not just sustainability of continuity of operations, but also, you know, are we doing things that are good for the environment? Are we doing things that are good for the community? And, you know, that all needs to be wrapped in to these conversations and considerations as you begin to make decisions based on systems.
Thank you, Jason. And Abby, I'm curious if that sustainability piece resonates with you.
It definitely does. At Children's Health, our mission statement is to make life better for children. And so part of our responsibility as a healthcare provider is to look at the bigger picture and the impact that we have on our communities. Hospitals are one of the largest consumers of energy, and so by making smart decisions to be more green, promote sustainable practices, and utilize cleaner energy and you know, cleaner emissions, we can be better stewards of our resources and overall improve the environmental conditions for these future generations, especially as a children's hospital.
And if I could chime in just for a second, this is Mike again. One thing that I think is really exciting to me about the possibilities of this in the future is, you know, there is the possibility that these generators could be switched to a propane kind of capability, and you could have on-site storage of that gas to be able to actually perhaps become your primary source of emergency power and not have to have the diesel generators as the backup. That's something that we would be very interested in looking at down the road as a possibility. You still have the natural gas capability of providing these, but you could also switch to propane if necessary, and that would even make this even more affordable as we have to consider replacing these diesel generators at some point in the future if we don't need to do that because we have the ability to add on to the existing natural gas generators. So something to think about as well.
Thank you, Mike. Did anybody have anything? Alan, maybe Abby again, anyone want to weigh in once more here on this question before we move to our audience Q&A?
This is Alan. The sustainability topic is one we're hearing more and more, and you know, a diesel generator, a tier 2 diesel generator, and even a more expensive tier 4 diesel generator just it can't be as clean as the cleanest natural gas microgrids. Factor of hundreds or even thousands of times the emissions occur when a Tier 2 diesel generator is operating. And it's ironic that in a health environment where respiratory distress could be immediate when a diesel generator is running, we should be all looking at ways to improve on local air quality as well as global emissions and sustainability initiatives for healthcare. We've got an initiative where we're now using renewable natural gas that is a negative carbon option for these backup microgrids. And so it is still cost effective. There is still a market revenue stream that can be accessed with those kinds of technologies. And in particular in California, there's a strong appetite for that kind of an option where you can get indefinite operation and still meet sustainability goals for carbon and local emissions.
Thank you, Alan. It does just seem, I think that's an important point to sort of make there. It seems like cleaner power kind of folds into, healthcare's mission of, driving better overall health in the community. So I just want to thank our panelists for that great discussion. I think it was very informative and engaging. And we'll now begin today's question and answer session. So as a reminder, please submit any questions you have by typing them into the Q&A box you see on your dashboard, and we'll get through as many as we can. Let's begin here with this question. So the attendee asks, what happens if a natural gas line is impacted and you lose gas service? That seems like an important question there. Alan, would you mind taking that one?
Sure. I used to work for a gas utility, so I know this one pretty well. The natural gas infrastructure is incredibly robust. It's not that there aren't occasional gas line issues, but it is typically a loop feed system where there's multiple pathways for gas to be delivered to a site. And we always work with the local gas utility to ensure that any vulnerabilities in that architecture are known in advance, but there have been studies done that shows the natural gas energy infrastructure is by far the most reliable energy infrastructure, particularly compared to above ground electricity. And as a consequence of that, natural gas interruptions, usually from some kind of a construction dig-in is the most common, are not correlated with electric emergencies. Power outages and the very rare natural gas infrastructure impact don't happen at the same time. And if there was a fallback, the on-site fuel storage associated with either the gas generators or the diesel backup could continue to carry the emergency loads. But we just don't see natural gas lines interrupted in this manner, and you don't have issues with flooding, with winds taking trees down. All of the infrastructure that's above ground is far more vulnerable, and so it's a risk trade-off. In the Gulf Coast markets, it's difficult to get diesel deliveries when there's an emergency because of floods and road closures due to trees. So there's risk in, I suppose, any energy system, but natural gas has been studied even by the National Renewable Energy Lab and shown to be a more reliable fuel supply for backup power.
Thank you so much for sharing your expertise there, Alan. Appreciate it. The next attendee question we'll take is, the attendee asks, how important is the structural system, i.e. lateral system, when designing a resilient hospital? Abby, you want to start us off here, and then I'm happy to have anybody else weigh in if they'd like.
Sure. And in my mind, since I'm an electrical engineer, I think of the lateral system as it refers to utility. So I hope that that's what this means, and maybe Jason can take it as more of a structural piece. But that is definitely something that we look at when looking at a resilient hospital. We look for dual services coming into our facilities. And so we also look at the placement of the substations. We want to be fed from 2 different substations, and we don't always get to control where those substations are located. We try and get them from opposite ends of, just geographically, but we don't, as a user, we don't really get control over where those lines are routed or how the feeders are routed to our property. And so, you know, there's always the risk if they're close together or the feeders are routed along the same pathway that a natural disaster could take out both services at one time. So again, I think for resiliency, it's all about having options, understanding where the vulnerabilities are and, you know, what are you going to do if those fail. But it is definitely something that we look at for designing a resilient electrical system.
Yeah, and I would just say, and when it comes to the physical structure of the building, columns and beams, et cetera, absolutely it's important to consider when you're talking about resiliency. Of course, code is going to already require a minimum type of structural system based on building type and location. And so that's the first place you need to go just to determine what's the minimum standard, and then begin to think through your risk assessment, you know, to maintain safety and continuity. What else do you need to do in addition to that so that your building can be maintained during an event?
Well, thank you both, Abby and Jason, for weighing in from those different perspectives there. We've got another really interesting question here I want to put to the group. So, can your full facility redundancy systems be a differentiator for marketing the hospital over time?
Well,
I would say
I'll
absolutely.
take yeah.
Mike, you're probably living that now, knowing that you do have a competitor in town.
Right.
I would say absolutely that could be a differentiator in how you talk about it, and if people know that, you know, you're designed for certain events, it could definitely be a place that reminds people of safety and continuity for sure.
Yeah, this is Mike. I'll just chime in. Absolutely. We've had extensive discussions with our medical staff about the capabilities that we have, and it's been very reassuring to them to know that in the event of any loss of power, that we will be able to continue to operate. Our competitor will have challenges. You know, we will be able to have air conditioning, we'll be able to have full service, continue doing operating room procedures, ER, everything. The other hospital will have some significant challenges in being able to provide that full service. So it is a definite competitive advantage, I think, from that perspective, and something that's you know, a market advantage, I think.
This is Alan. Let me just add, if I could just add one more point. We're finding this across lots of industries now, not just in the healthcare field. The idea of continuous power availability that allows you to continue normal operations and serve your customers of any type is a benefit that these microgrids provide to other industries. Manufacturing industries can meet delivery schedules for their product shipments. Grocery stores can continue to deliver food and medicines to their customers. One of our customers even provides emergency Wi-Fi in their parking lot when there's power outages in the area because they have power and the surrounding neighborhoods don't. This idea of creating a closer customer relationship and higher level of differentiation in the market, I personally believe that that's possible when you have reliable and continuous power supply and your competitor may not.
You know, absolutely. I think go ahead, Abby. So sorry.
Oh, no, you're good. I was just going to reiterate also kind of what Mike had said earlier. You know, I don't think any hospital wants to send patients away. And in the event of an extended outage, you know, you don't want to have to send patients to another hospital. And so by having that full facility backup, you know, that becomes a non-existent issue. We'd rather have people coming to us when they need help, and it's safer for our patients to stay in the bed rather than having to transport them to another facility. And so, yes, I definitely think it could be, it's something that will differentiate us from others.
I think recruitment and retention, too, could be a big piece of that. We've had clients that have tried to make some resiliency decisions also based on, you know, recruiting the best caregivers, physicians, and staff and keeping them. And a lot of times it can have to do with your investment in infrastructure and systems.
find that recruitment piece fascinating as well. In healthcare, it's not just about sort of building trust within the community. They're trusting you to be there, but also trust among your staff as well. The next question then, I want to get to this one just because I think it's so obviously on everyone's mind. So how has COVID-19 changed your thinking about resiliency?
I'll start that one off a little bit and just kind of share with some of the thinking that we're doing at HKS. We've always approached designing hospitals with the idea of flexibility, and because the majority of our clients are making investments in buildings that are going to be 50-year buildings, and so we really want to think about how can you design enough flexibility so that over time you can maintain operations, knowing that technology changes, medical equipment changes, everything changes. And so while we think we've been designing flexible facilities, one of the things that has really hit us and what we've learned from COVID is that we haven't designed facilities that can flex rapidly enough. And so if you think about the onslaught that some regions took based on COVID cases, it wasn't as though that they had inflexible facilities. It was just that their facilities couldn't flex fast enough. And so we're really starting to rethink what does that mean in terms of planning and design, and how can we help our clients prepare better for that in the future. And in some cases, it does require some redundant systems and some kind of metaphorically some switches that you can flip to go to pandemic mode relatively fast. In the case when you begin to get more and more cases come to your facilities. But generally, that's kind of where our minds are right now in terms of rapid flexibility. What can we do to help clients achieve quicker flexibility?
And I'll add to that. This is Mike again. Basically, you have to be here for your patients. That's why we exist as hospitals. And these patients who have COVID need care and treatment. And to be able to transport them somewhere else is difficult, and it exposes other people and all those sorts of things. We had, as a hospital, to convert whole floors to negative pressure to accommodate the surge that we had in COVID patients. And that requires a lot of things, but it also requires power and resources to be there in the event of if we were to lose power, we would have not been able to take care of these patients who are desperately needing the care. Ventilators and other kinds of things. You only have so many red plugs available, and we had literally 65, 70 patients that were requiring that level of care in our hospital at one time. And for us, that was a large number of people who were needing the specialized care. So having that resiliency and backup capabilities gave us greater comfort in knowing that we could take care of them locally here and not have to send them out of town.
Excellent. Thank you both for weighing in there. The next question, this attendee is asking for your thoughts on storing your data offsite for hospitals to avoid disasters and save costs. Mike, Alan, I'm curious to hear what you would have to say on this one.
Go ahead, Alan.
Data is one of those costs, storing data, but accessing data during a power outage is one of those costs that I think doesn't get as much attention as canceling procedures might, but we are a much more information dependent industry, and having the data stored offsite, I think, is a good example of how to create resiliency in the rest of the infrastructure. You still need to have power at the hospital in order to be able to access that data that is offsite into the cloud, and it's not always going to be on the critical circuits. So I think full facility backup is complementary to the idea of distributing the data repository where it can be offsite in the cloud with the right kind of security protections that the healthcare industry requires, of course, as well as whatever is stored locally, accessible to the caregivers.
And I think you answered that very well. And all hospitals are looking at this, trying to anticipate, in a natural disaster, you don't want to have everything in one location where it can be destroyed and not have access to it. So all hospitals are exploring that, but exactly to your point, you need to be able to access that data and that information, and having that resiliency and capability is vital to be able to do that.
Appreciate you both tackling that one. And so for this next question, this sort of circles back to the sustainability piece we closed our panel discussion on. And so Abby, I know you had some fascinating stuff there. I'd love it if you maybe started us off on this question. But the question is, my hospital organization is serious about lowering emissions. Can the microgrid system help along these lines?
Yes, I think definitely it can. I mean, looking at our traditional diesel engine generators, right now at our site, we had tier 2 engines, which, it's not the best for emissions as far as diesel goes. We definitely prefer a tier 4 engine. I think there are a couple manufacturers of tier 4 that can't be used for emergency purposes. They have to shut off when emissions go out of range. And so, that was another factor in looking at natural gas option. Having that as an option where it just runs cleaner, the emissions are better. It's just cleaner than its diesel counterpart for sure. And that was important to us.
Maybe I can add a little bit of local color too to the decision related to emissions. It is important, as Abby said, that some of the more advanced emissions controls that are required for diesel do have really tight measurement tolerances, and they are required to shut off if they fall outside of that range. That is a problem for the emergency function that they're put in place to serve. The nice thing about the natural gas emissions, they're inherently cleaner, and we operate about 200 or so of these microgrids in various parts of the country in different industries. And being able to support a reliable operating fleet of generators where we have actually over 500 separate generating units at those microgrids means that we're looking for the highest availability technologies that deliver this reliability to our customers. In the case of air emissions, we use solid catalyst treatment instead of having DEF fluid that is often required, especially for tier 4 diesel generators. Those are problematic, and a solid catalyst is very low maintenance, extremely reliable. It's similar to what is in vehicles. And because of that, the high availability of our units means that we're available providing power to our customers when they need it, when combined with utilities, 99.999% of the time. It's only the 10 seconds that we take to start up when there's a power outage that we're not providing power or the grid is not available. That ultra high level of reliability is what a microgrid can provide, especially in the model where a service provider specializes in that expertise. And in our case, we have a 24/7 NOC that is monitoring every system all the time to make sure that it's ready to go if there was an emergency. That level of high availability means that hospitals can focus on patient care and other priorities rather than worrying about whether the diesel plant started up or is going to stay operating.
Absolutely. So important points there around, it's peace of mind to really know that this you're going to be able to operate in the face of a crisis. And just as a reminder to folks, I think it's important if you want to engage on more questions or about this topic. Sort of Enchanted Rock has some wonderful resources and white papers on their website. I think there's a lot of information available on everything we touched on in this discussion. And with just a few minutes to the top of the hour, I'm thinking this is a good place to really I want to check in with the panelists and see if you have any final thoughts you'd like to leave for our attendees today. Anything at all. Alan, do you have anything you'd like to add?
Well, I think that going back to the survey, there were 27% that were interested in looking at this as an option, but 9% thought it was going to be too expensive. I hope maybe we've addressed the affordability of this full facility backup. We'd be happy to go deeper on any discussion related to what your local circumstances would look like. But full facility backup is affordable when it's done through a clean natural gas microgrid as a foundation technology, and I think it will end up being more standard than ever going forward, that full facility backup is what hospitals will do to provide patient care that is their mission.
Thank you, Alan. Mike, any closing thoughts from you?
Just echo what he commented on. I think this is a futuristic opportunity that everybody should be considering and looking at to maintain a resilient hospital that's capable of being available for your patients in any circumstance or situation that we may find ourselves in, from either a pandemic or from natural disasters or power outages or other things that may occur. We will be here and be able to take care of our patients as a result of having this system in place. And we've been very pleased with it and feel very blessed to have that as available in our community.
Thank you, Mike. Jason, anything from you?
Yeah, I would just say it has been a great conversation. Appreciate all the answers and such and the way it's gone. In terms of resiliency, it's always been part of what we do and how we've approached our work with clients. But now more than ever, it's front of mind, and it will, these conversations will begin to drive design solutions more than they ever have before. And so it's just so important to go through these conversations, these risk assessments, to talk about safety and continuity, to prioritize and determine with each design, each client, as to what needs to be addressed. And it's just more important now than ever.
Thank you, Jason. And Abby, I'll give you the final word.
Okay. I was just going to say, I think it's a really exciting time. Being an electrical engineer and designing hospitals for a long time, it was usually pretty cookie cutter almost on how you do that and what would be provided. And with these newer technologies, it's really exciting. We're thinking outside of the box more on what are the possibilities for our hospitals now? What can we do to make it better? What can we do to improve resiliency? How can we be better prepared for the future? And so it's so exciting to be a part of this and go through this. So it's been a lot of fun.
Thank you, Abby. Panelists, it's been great talking with you today. I also just want to thank Enchanted Rock for sponsoring today's webinar. And as a reminder to attendees, please check out our resources section on your dashboard to view the resources that were mentioned today. Enjoy the rest of your day, everyone. We look forward to having you join us for future webinars.